Hi, José Fernando.
Hi, Anna. How
Great
are
to
you?
see you.
Nice to see you too.
So, today my guest is José Fernando Gonçalves. He's a principal research scientist at Amazon with contributions in the fields of OR and applied mathematics. He's most known for his work with meta-heuristics, in particular biased random key genetic algorithms, as well as for his work on the job shop scheduling. His areas of expertise are optimization, heuristics and meta-heuristics, scheduling, cutting and packing, facility layout, inventory management, and OR modeling. He has published over 50 papers on combinatorial optimization and edited a book on inventory management. José Fernando is on the editorial board of International Transactions in Operational Research, and he was a professor at the School of Engineering and the School of Economics of Porto University from 1986 to 2016. José Fernando, thank you so much for accepting the invitation. I'm so happy you're here. Tudo bem? How are you?
I'm fine, thank you. It's my pleasure to be here.
So you were born in 1959 in the city of Porto in Portugal.
Yes, I'm very proud. Do you know that Porto gave name to Portugal? The name Portugal comes from Porto.
Oh wow, I didn't know that.
Yeah, but now you know. Okay, so there are two cities, Porto, and the other side of the river, it's called Calen. So originally, they put together it was Porto Calen, and then the name evolved. Okay,
Wow,
but that's
fascinating.
yeah. So
Uh,
we are very proud because Portugal has name in our city.
Excellent. And what about your family background?
Okay, my family background is very humble. Okay, both my parents come from the country, and my mother's family, most of them were, in the furniture making business. Okay, and my father was a shepherd. He was taking sheep to the mountains, and then he would go for a month or so. He would come back. My mother, they were really poor, so in, my grandparents, they didn't have enough money for all those 11 kids. So she stopped studying when she was 8 years old, and she went to work for some rich people in the area where they were living. Okay, and she would live just there, and the only payment she was getting was food. And she worked like that until she was 20 years old.
Wow, so she was working for free.
Yes, like a, well, almost a slavery.
Wow.
Yeah.
Uh,
So those times were very difficult. It was also during the war, the Second World War. So the country was also very poor. So it was very difficult to live that time.
yeah.
My
And
father, my father was also difficult, but at least they had enough food. So they didn't have a very good conditions. So my father didn't know how to read until he came from the army. So I think he finished primary school at night by the time he was 30 years old.
wow. Yeah, so your parents really have a humble background. And you mentioned your mom had a lot of siblings. Your dad also had many siblings, or there are only a couple of kids around?
It was the same number, 11. They were 11. 11 for my mother and 11 from my father.
Wow, so 20 uncles and
Yes, yes.
aunts.
And lots of cousins. Okay.
Yeah. Wow. So your parents own a restaurant, and you used to play there, and
Yes, so after my parents got married, the skills that my mother had and my father always wanted to have some business. So my mother learned how to cook very well, and how to sew too. She could make some clothes. So they decided to start a small restaurant. Okay, so initially they start a large restaurant. It was a little difficult to manage, so then they changed to a smaller one. So most of my life, until I graduated from university, I spent it at the restaurant, okay, with my parents.
Mhm.
So it was also hard life because you have to work all the time. You cannot stop during Christmas or Sundays because that's when you have the customers.
Uh-huh.
So, but I had a good life. They provided almost everything I needed. I was lucky because engineering was in Oporto. I could find the university. If it was law school, it would have been a lot more difficult because I would have to travel to find some lodging. So that would probably cost my parents a lot more money, and I don't know if they could do it.
Mm.
But since the university was within a walking distance, I could go every day, and but I had everything. They provided books. I had no complaints, and I didn't have a car like my colleagues, but I had enough, to go to school,
Right.
books and food and everything.
Uh-huh. You mentioned that you have many uncles and aunts. So I was kind of expecting that somehow you had some type of family business, but apparently they started their own business independently. And I think you mentioned once that you have one particular aunt with 23 children.
Yes, she had 23 children. See, my uncle, he wanted a boy. Okay,
Uh-huh.
so he kept getting girls. So he was trying to get a boy, and for some reason the boys had a problem. So they would be born, and then maybe after 2 or 3 years they would die.
Uh-huh.
So we would try again, and they tried until she got 22 kids. Okay, so yeah, it was
It's
lots of kids.
yeah.
Yeah, but they didn't have TV at that time, so.
Yeah. So I have a curiosity. So when you were attending classes in school, how the former Portuguese colonies were presented?
Well, at the time that I was a kid, there was still, a dictatorship in Portugal. So all the colonies were presented as a big thing from Portugal, a small country that is able to, go to Africa, to Brazil. Brazil, I remember, they were always saying, okay, Brazil is 100 times the size of Portugal. It was very, very important thing. And Angola, I think it was around 14 times. So the colonies were presented as a very good thing from us, okay, and it was something to be proud. Okay, I remember that I was in some school provided by the government at the weekends where I would have to transmit signals with the how do you say, flags.
Uh-huh.
You would have to show flags, and one of the things that we had to transmit is Angola belongs to us. Okay, that's the thing that we had to transmit. So I think the state was trying to convince everybody that Portugal was very, very good, and that was a kind of way of keeping people united and forgetting about democracy and all that. Okay.
Right.
So it was like a brainwashing.
Ah, okay. You grew up during the dictatorship regime in Portugal, as you mentioned. Do you have any memories from that period outside school?
Well, the things that I still remember is that sometimes, students that were at university, they would protest. And I remember the police going after the students and beating them. So
Oh.
that I remember. But when the revolution happened, I think it was in 75. So I was 15, 16 years old. And I was not too much into politics. Okay, in fact, I didn't know there were politics before.
Mm-hmm.
I knew those problems, but that's what I remember. I remember there were also some political police that if you were against the regime, they would put you in prison. Okay, I know, and everybody had to be careful. I remember my parents told me, okay, don't mention this, don't mention that. But other than that, I think, with 15 years old, I was not too much into politics.
Mm-hmm.
So that's all
Right.
I can remember.
Mm-hmm. And what happened after the revolution in 1975?
Okay, there were good and bad things. Okay, the good things were, the fact that we received lots of people from the colonies. Also, right after the revolution, there was a big influence of the Communist Party. So the Russian Communist Party had a big influence. So we were about to become a communist country. But then 6 months after, there was another kind of mini revolution that was going the other way, maybe a little more to the right. But in the end, the things got balanced, and we start having lots of party, from the right, from the left, from the center. That was a problem because there was no stability.
Hmm.
With so many parties, no party had majority, so it was difficult to have a government that would last a long time. Most of the governments would last between 6 to 1 year.
Hmm.
So we kept changing, governments until maybe the 1990s, okay, when the things got a little more stable. The colonies were a problem because we received almost 1 million people, okay, so let's suppose it was around 10% of the population, okay, and those people came without anything. So we had to provide, houses, food, and some of them also brought some bad things, like they lost everything, so they start bringing some drugs like marijuana and selling it. Other ones brought good things because they are entrepreneurs, so they started, new companies, because in the colonies everything was new, so everybody that went there wanted to do something new. In Portugal, most of the companies, they belong to some rich people or families that have been there for a while. But after the revolution, they ran away. They went to Brazil, country that you probably know.
Yeah.
Okay, so now they are back. Maybe 20 years or 30 years. But at the time, they ran away, and so it was very difficult during those times. The police was also losing some of the power that they had before, so keeping the order was difficult.
Hmm. And you witness many difficult situations before and after the revolution, and how that affected your personality or your views.
Well, one thing that I don't remember so well is that, what was happening before. I know that the students were not something that the government liked, because they were usually new ideas, they were asking for democracy. But then I remember that when I went to the university, almost every week, there were some meetings to, let's discuss this, let's evaluate that professor, he's a fascist, he's this, he's that. So everything changed. I remember those times, where there were mini revolutions everywhere, in the school, in the universities. I think it was good. I think now one of the big things that they did was the health system. Okay. So the health system was something that came out of the revolution, and it's free or almost free to everybody.
Hmm.
And studying is also free, but it was already free before. But the health system and the pensions, so everybody can go to the hospital. They don't ask you if you have money. Okay, you
Hmm.
get treated, and whatever you need. The public hospitals are the best ones.
Hmm.
The only thing that you may find is that sometimes there is a waiting list.
Hmm.
But other than that, I think our health system is quite good.
Hmm. You were mentioning the university. You have a major in mechanical engineering. What was the motivation for choosing this degree?
Okay, so my godfather, he had a small business where he was selling parts for cars. So I thought he was a mechanical engineer, okay. And I liked also to make machines, build things. So it's okay, mechanical engineering, it's a good thing. It turned out that I could have gone to any engineering, okay, because now when I look there, they are quite similar. And mechanical engineering, I thought we were going to make engines and machines. Okay, so we learned some of the theory, but most cars and machines, they come already from Japan or Germany or Italy. So there's not a lot of opportunities for you to make machines. Okay,
Hmm.
if I could decide right now, I would probably decide on civil engineering because you can make houses. Okay, or computers. Okay, computers right now, it's something that you can find good jobs, and computer science, programming.
Hmm.
But at the time, I got to mechanical engineering.
Hmm.
Okay.
In Brazil, it's not common for one to take OR classes in a mechanical engineering program. How about in Portugal?
Well, when I got to mechanical engineering, there was some. The director of the department, he had been in the industry, and he knew that most of the things that a mechanical engineering end up doing are related with management, and they knew that OR could be applied. So they start sending people to England, to specialize in operation research. So by the time I got to the third year, so my undergraduate was 5 years. So we had operation research on the third year,
Hmm.
and we also had programming on the second.
Oh.
Okay, so I learned in my case I learned no, not visual, but
Hmm.
basic, and then I learned operation research because there was one of those guys that already went to the to England and came with a degree in operation research. So he was teaching us, and most of the things we were doing was modeling using mass programming, and solving it using simplex. Okay, but it was manual simplex.
Hmm.
I remember, the professor giving us some copies of the Danzig book.
Yeah.
Uh, so it was fascinating because you could model some business or something, and you didn't need that many resources. Okay, all you need was a computer, and you could write. So that interested me a lot. So by the time I got to the last year, I was offered by some of those professors that came already with OR if I wanted to go and get a master and a PhD. And initially they wanted me to go into quality control.
Uh-huh.
Okay, so I think quality control was important that time because the Japanese were using it to produce high quality
Hmm.
cars. I
Hmm.
remember a name that was very famous, Taguchi.
Ah, yeah.
It was Taguchi. But they try to find, okay, let's find a university that is good in this area of quality control. So there was something in Quebec, but then it was a little late at the time to apply for it. Then we consider also another place in Canada. It was Manitoba,
Mm.
but it was also difficult because they were following a different, until somebody suggested Berkeley. Okay, you say, okay, the IOR department has some quality control. So I end up coming to Berkeley.
Hmm.
Okay, it was a difficult process because I had to take the GRE exam at the last minute. Then they lost the results, so I couldn't come with that exam. So I ended up coming with the British Council certificate of English, and they accepted me. Okay, at
Hmm.
Berkeley, and they also looked at my grades. So I was the best student in my year.
Hmm.
So they end up accepting me, but I came. At the time, Berkeley was using the quarter system, so it was 3 months, 3 months, 3 months. Okay, so I came in the middle of the quarter, so it was difficult to follow.
Hmm.
Okay, because everybody was already in the middle of in 10 weeks or 12 weeks, they were already in the
Hmm.
6 week. The people, the colleagues are also difficult because in Portugal you help each other. Here nobody helps you.
Uh-huh.
It's difficult. If you ask, or do you have some notes? No, I don't have any notes. Okay, so the beginning was very difficult, and I came in the middle of February. That's when I met Mauricio Rezende. Okay,
Uh-huh.
and so I came with my luggage, one in each hand, and I went directly to the department. Okay, and there he was, Mauricio. He was like a guardian angel because he helped me a lot. It
Mhm.
was, and he was speaking Portuguese, or at least a kind of Portuguese. Okay, yeah, he was able to understand me well. I because even when I go now to Brazil, some people think I'm from Argentina. Okay,
Ah.
so he was able to understand me.
Yeah,
So
but José Fernando, before you continue with your story of the masters in Berkeley, uh, at some point while you were still in Portugal, you implemented the simplex algorithm in BASIC. Was this part
yes,
of was this part of some task, or you decided to do it just for fun?
okay. So you probably, I don't know if you know, you are younger than me,
Yeah.
but at my time, simplex, everything was by hand.
Mm-hmm.
Okay, so it's very easy to make mistakes, and it's a very tedious. So at the time there was a computer called Sinclair that was developed in England, and I even went to Cambridge to buy a small packet, like a package of cigarettes, was 16K. Okay,
Mm-hmm.
so I was able to put in memory around a matrix maybe of 50 by 50, and I decided to code. The steps that I was doing. It was not the revised simplex; it was just the Tableau.
Mm-hmm.
So yeah, so I coded that. It was not very efficient, I guess. If the scale increases, probably accumulate some errors because I was not doing that much, fancy things. But it was fun. I could make now the tableaus right.
Yeah,
The only
actually.
thing I was not able to do, or I didn't try so much, is that sometimes you'd like to write it as a fraction, like 1 divided by 3,
Uh huh.
and I would get 0.333. But most cases I could transform that into. But it was fun because I was able, to make some larger mass programming and then
Mm-hmm.
put it in there and solve it.
Mm-hmm. And how was the situation of OR in Portugal in the early 80s? We're talking about 40 years ago.
Okay, so in the early 80s it was starting to be developed, okay, because some of the companies, like I said, there were some of those professors that were coming. There were some logistic problems that we could use. There was also production planning, organization. Computers become important in the management. Okay, so it was starting, and some companies, were starting to ask for people to do some of those jobs. But I guess until the 90s, that's when it really started developing.
Mm-hmm.
But since Portugal is a small country, it's not as developed as it probably is in Brazil. Because in Brazil, if you save a little bit, you save a lot of money because it's a large. Okay, in Portugal, even if you have logistic problems, there is not a big distance, so there's
Mm-hmm.
not a lot you can save. Okay,
Mm-hmm.
but in terms of industrial organization, I think it was the most important thing. Layout, the concept of material requirements planning,
Mm-hmm. Yeah,
quality.
MRP.
Quality was also something that was required because they are trying to copy what was being done in Japan,
Uh huh.
making some rules for quality
Uh huh.
certification. So I would say that around the 90s, that's when OR start
Really
being.
took off.
Yeah, yeah.
Yeah. Uh, so, were you aware that Berkeley was a very prestigious university when you arrived there?
No, I had no idea Berkeley existed. Okay, so Berkeley, I knew the name MIT, Harvard, but Berkeley, it was not on my knowledge. I learned later that it was very good in terms of OR, and it was competing at the time with Stanford because some, Danzig, I think it was in Berkeley
Yeah.
when, and then he moved to Stanford, and many other, people that were good in terms of OR. They were from the IE OR department in Berkeley. But
Hmm.
I had no idea it was good or bad.
But you spent an entire year without receiving grant. How did you manage to survive?
Well, when I came to Berkeley, I was supposed to have a scholarship from the Portuguese government, but the inflation was very high in Portugal, 30%, not as high as it was in Brazil, but 30% was a lot. So some people were keeping the money in the bank, okay, and they didn't send it to me, okay. So the first year in Berkeley, I was able to delay the payment of the tuition, and to survive, I had to work for the transportation department, okay. I would go to San Francisco between 4 and 6, and I would count the cars that go in one direction, turn left and right, and they would pay me $12 per hour. So I was surviving with that.
Wow,
Yeah.
that's interesting. And did you have to write a dissertation to obtain your master's degree?
Yes, it was like a mini dissertation. I did it in quality control. Okay, and also it was a little bit, related with reliability,
Hmm.
because at the time that was the thing that was most close to quality control. Okay, it was Professor Barlow. So I did something, in evaluating the reliability of a system that had some parallel. So I again wrote some code in Visual, not Visual, in Basic.
Hmm.
Okay, so Basic was at that time a difficult language. It was the only one, but it was difficult because of what they call now spaghetti code. There were no local variables, so you had to be very careful, how to use. And memory was also a problem because you had to reuse variables.
Uh-huh.
So sometimes you were using the same variable, but you were forgetting that it was supposed to be, you know, some other values in there.
Mhm.
So that was the cause of
Yeah,
making some of
debugging
those.
codes,
Yeah,
I think,
debugging.
was hard because of many go-tos.
Yeah, yeah. And then using reusing the variables was also a problem.
Uh-huh. Yeah, you also did your PhD at Berkeley, right?
Yes, so I did my master, and then after 1 year, I had to come back because initial. So once I came back, I finally got the scholarship. The money came. I was in Portugal, but in any way, I prepared in such a way that I tried to do what they call a prelim exam, so that I could go into the PhD. And when I came back, I was able to extend the scholarship.
Hmm.
So I came back again, in January. I went back in December, and I came back in January, and pursued the. But then I changed, instead of being quality control, I went into production planning,
Hmm.
which I liked more.
Hmm. Did you have to take additional classes?
Yeah, I think it was a year and a half more
Mm.
of classes, doing, many. And they also asked for some classes in different departments. So I had some classes in statistics, in mechanical engineering, in business.
Mm.
I had accounting. Accounting was an error because it's really boring. But so I had to do that. And then after that, you have to prepare for what they call the qualifying.
Hmm.
Okay. So during that time, I was taking classes, and I was also working as research assistant.
Oh,
Okay.
and how did you handle the pressure when preparing for exams and the qualification?
Well, I think after the first year, everything was easier
Hmm.
because the first year was the really tough one. Okay, I didn't have money. I didn't, know the country. So after that, I already had some money that was left from the previous year. I got the research assistance that would pay me and I was working on something that I really liked. Production planning was a little more in my area than quality control.
Hmm.
So there wasn't that much pressure. Okay, I think it would have been better if my family was there or so, but other than that, I think it was okay.
Okay. And what was your PhD research about?
Okay, so I did two kinds of things. One of them was related with Intel. Okay, So Intel was using MRP, material requirement, to do the planning of the. So what we did is that we tried to change MRP, which is a discrete oriented tool, into a continuous one, because that's more or less what the process of making semiconductors is. So we kind of created a MRP, rate-based MRP. Okay. And then the second thing was, since MRP does not handle capacity, so you determine the quantities using the lead times, but sometimes you are asking too much quantity in a certain period. So we try to make that rate-based and formulate it as an LP, a large LP, that would take into account the lead times, the rates, and the capacity. So if I could not do something in a certain time period, I would move it to the next one. And that was most of the things that I did for Intel. At the same time, I also worked for, not directly, but my supervisor, he was working, supervisor, PhD advisor. He was working also for a company that sells detergent, Clorox. And they had a classical problem, which is a single machine where you have to produce several products. Okay? And every time you change the product, you have to clean the machine. So there is a setup.
Setup time, yeah.
Yeah. So then they wanted to extend where you have many products and you have many machines. And the problem was, you want to minimize the cost of carrying inventory, but you also want to minimize the cost of having to change all the time. And you want to avoid shortages. So that was the main difficulty. Avoiding shortages was very important, because if you have 1,000 products, and there are always some products that are going to run out, okay? So you have to, at the same time that you are scheduling, you have to change the quantities, so that, okay, let's suppose that I have 50 products that are going to run out tomorrow. So if I only have 25 machines, then I have to make sure that I maybe make some today and make some tomorrow, because I cannot make 50 products at the same time, since I only have people. So I did something that adjusts dynamically the time when you have to start producing, and also the quantity, so that you minimize the cost, but you also avoid shortages.
Yeah, so you work with planning and scheduling in your PhD.
Yes.
Yeah, the research. But did Intel put the results of your research into practice?
They applied it, okay? So my PhD advisor, he ended up, taking the code that I was developing, and he made it into a system. So he was selling it as a consulting to Intel, and later to AMD. And then later, I think he even went to Korea, and he did it in some of those, semiconductor companies.
Yeah. At the time, you were coding everything in Fortran.
Yes. So the coding, most of it for Intel was in Fortran.
Right.
Yes.
And when you had to solve MIP models, how did you do it?
Okay. So there was some package, that we had there that could solve MIPS. In our case, for Intel, most of it was rate oriented, so we could go, get just continuous variables. Okay, so it was a quantity. If you round it, there was no problem. The problem that I did for Clorox, where there was that one required 0, 1
because
variables.
It's a sequence. You cannot just.
So that one was not. I was not able to. So I could model it, but the quality of the solution was really bad. In some cases, it was even difficult to get one feasible solution. Okay. So I had to change the model and combine a heuristic with the MIP.
Right.
Otherwise. So I don't remember the name of the software that we were using, but
was it by IBM?
It was by IBM, I think. It was. Yeah.
Your first conference experience was a bit disappointing.
Yes, it was. I remember that very well. It was in New Orleans. It was one of those. I don't know if it was Orsa Teams conference. I now, but it was scheduled in the last day, in the last session. Okay, so I guess there was my advisor there and maybe another person. So there wasn't that many people attending. So it was not that good, but
Yeah, it
it's okay.
happens. Yeah. No, I think it's good for listeners to hear that because that might happen to them, and for them not to feel that bad because it's just part of it. Yeah.
Yeah, during the time I was at the conference, I said, "Well, I'm glad that I'm at the last one. I can prepare for it." But then I saw that they when they put you at the end, that means they don't care much for what you're going to say.
Yeah, that's debatable, but I understand your point. Yeah, you finished your PhD in 1987 and you got two nice papers from your thesis. One appeared in Management Science and the other one appeared in eJour in 1998. Why did it take so long for them to be published?
Okay, so when I went to Portugal, I wanted to pursue that, but there was no email, there was no TROF to write because at the time there was a kind of LaTeX that I had written that, so TROF was not available. And then I was a young professor, so what they do at the University of Porto is that they give you a lot of bureaucracy. Okay, so I was head of department, I was head of HR, so I had to do all those things that are not really
Yeah,
important.
tons of administrative work.
Yes. Okay. And then when I was trying to get rid of all those things, I had to go to the army. So by the time I was around 30 years old, and the army called me,
Wow. I
and I
mean,
had to go.
it's at least in Brazil you do that when you're 18 or so, but doing that at the age of 30 is a bit unexpected.
Yeah, so in Portugal, I think it was around 21 that you were supposed to go. But
Oh.
since I went to the PhD, oh, no, not 21, you could do it after you finish. So around 22, 23. But since I went to the PhD, I had to postpone it. So
Mhm.
I asked for a postponement. Sometimes they would say yes, sometimes they would consider me. I don't know, those people who ran from the army. I don't know what is the word in English.
Mhm.
So once I got back, I thought they would call me, okay, but no, they waited 2 or 3 years, and then they called me when I was 30,
Mhm.
and they put me in the Air Force because I was a mechanical engineer. They thought I would be a good aeronautical engineer, okay. So I was doing those times with people who were 18 or 19 and
Mhm.
they wanted to be a pilot. I didn't want to be a pilot, but I was there. So I wasted 1 year of my life, just there, fighting an imaginary enemy. They teach you how to, manage guns. They take you to the country, and you have to be there 2 weeks without toilet paper, without taking a shower, and you have to learn how to, find directions with the stars, things like that. Okay, so that's what I learned. I already forgot everything, but that was trouble. So that wasted also another year of my life. And then,
Research wise, you tried to work on scheduling problems too once you came back from the army.
so once I came back from the army, those team of professors were very active. So they created an institute at the university that would provide services to the outside.
Mm.
So I could work for other companies as a consultant.
Mhm.
So there was many projects, okay, and most of them were job shop, at least in the north of Portugal. Job shop scheduling, MRP things. So I start working in consulting, and that was also another way of getting a little more money
Mhm.
to do. So that kept me busy until maybe 94, 95.
Were you married by then?
I got married on 91.
Oh, okay.
91. Okay.
Mm-hmm.
So then I had a little more responsibility. I had to pay for a loan for my house and things like that. So I had to get some money.
Mm-hmm.
Still, the computer started being easier to buy, and I could find some version of LaTeX. So I start writing some code and some text that I did in my PhD thesis. So I end up having, the first paper with my advisor, the one in management science.
Uh-huh.
I think they even included some other person that was, doing some master at Berkeley with my advisor.
Mm-hmm.
And then later on, I already had enough code, so that's when the other one came in
So
1998.
you only had access to computer in the early 90s?
Well, computers that were able to, to solve integer, we had very small ones, and in mechanical engineering there were some that were good for structural engineering,
Mm-hmm.
but you could not have any simplex or any code like that. So you have to do it in a PC,
Mm-hmm.
and you had to do it on yourself, because at the time it was a mechanical engineering department, so there wasn't that many things in our area. There was something that was a little easier, was simulation. We did some simulation,
Mm-hmm.
especially visual simulation, where you show what's going on and people can say, okay, the problem is here. It's easy to explain to people, but in the end, mass programming for scheduling, it was very difficult because the models were difficult to solve. They could
Mm-hmm.
not scale. So that's when I changed direction in
Nine-
1994.
You went to a jury in Pennsylvania. You took part of a jury, a PhD jury, and that particular visit changed your life.
Yes, it's true. So I went to Lehigh, and while I was waiting for that jury, I had some time at the library, and it was something good because we have plenty of journals in there. You could make copies, something that was very difficult in Portugal. So I already had in mind something about genetic algorithms, but I didn't agree so much with the binary 0 1 genetic algorithm. So I was looking for something on genetics, and I found a paper by James Bean,
Mm-hmm.
which was random key genetic algorithms. Okay. So I found it very interesting, and once I came back to Portugal, I started implementing it, and I changed a little bit, that because the way they were doing crossover, they
Mm-hmm.
were picking two chromosomes at random. So I said, well, it doesn't make sense to make it random. I probably should pick the best one. Okay, so I start doing the biased random key at the time. I was not calling it, but I always did it biased because it seemed better. And it was something really easy because there is not that difficulty in programming it. That
Mm-hmm.
you don't have to, like for example, you have to invert a matrix. You have to know a lot of things, to the error. But over there, everything starts every time you evaluate a chromosome, so it doesn't accumulate. So it was something really enjoyable for me,
Mm-hmm.
and I made a library in Visual Basic, and I started using it for a job shop.
Mm-hmm. Did you struggle to publish the first paper using these new ideas?
Well, it took me, I think we published in a Portuguese OR, but one of them, which was in assembly line balancing,
Mm-hmm.
it took a lot of time, because it was in the Journal of Heuristics, and some of the referees, they wanted to, okay, why don't you compare with some other data? But the problem was that some of that data was not available. And interestingly, in 1998, that's when Mauricio came to Portugal. So I was presenting that, a summary of that paper in assembly line balancing. And I was explaining, okay, I cannot compare the solutions. I can only compare the values because the authors don't make available. And one of the authors was there. He said, oh, I can give you the
Solutions.
solutions whenever. You just send me an email, okay? So I was glad. So I sent the email, but until today, I never got any. So some of the referees were asking, why don't you compare the solutions to see? And so that made it a little difficult.
Uh-huh.
So that's when I start, collaborating more with Mauricio, because he was already known.
Mm-hmm.
And somebody that works in AT&T in the US, it's more reliable than a Portuguese that nobody
Yeah,
knows.
yeah, I know.
So I think after he saw what I was doing, he also started working on these kind of algorithms. And by 2002, I think we both published. I published the one on assembly, and he did something else with some other person that was working, or was an intern at AT&T.
But you didn't have the name by then, right? The biased random key genetic
No,
algorithm.
no, I was doing biased, but there was no name, okay, at the time, okay.
Uh-huh.
So that was defined around 2010, 2011.
Mm-hmm.
So around 2002, I started working a lot with Mauricio, and we realized that the most important things that we were doing, first, it was biased. Bias helps a little bit, but the main thing was that everything that we were doing was separating the evolutionary engine
Mm-hmm.
from the decoder.
Mm-hmm.
So we decided to write a paper that would explain that, and the name just appeared when we start writing the paper, okay. So Mauricio was looking at the things and said, oh, so you are really biasing it here, okay. So yeah, so let's call it bias. Okay.
Right.
So the name didn't come out until it was, I think, 2011.
Wow. It took a long time, nearly 10 years.
Yes, so the name is not really important. What we were doing, but now it's known as biased. But I think the most important thing is the separation between the
Yeah.
engine and the decoder.
Right, because you
okay?
can do the operations with the
Yeah.
chromosomes, and you don't have to mind about visibility checking
Yeah.
and things like that. And it's pretty generic, right?
Yes, and the good thing is that you can easily try different decoders
Yeah.
for the same problem. Okay, you can try one. Usually, the first one doesn't work. You have to make, and you don't have to change the engine. So the way it works, crossover, mutation, that is done. You do it once, and that's done forever.
Mauricio
so
even
that's-
published a library with Rodrigo Toso.
Yes,
later.
yes. So that also helped, the algorithm be better known, because people now have a library. They don't have to worry about coding it.
Mm-hmm.
They may have to change a little bit in some cases, but that also helps.
Yeah, we ourselves used. It's a nice C++ library. We can easily implement heuristics for several problems, and indeed, it's very helpful and practical.
Yeah, and now you probably can find in Julia, in Python. I think some of the authors, Carlos Andrade. I think he took the one from Rodrigo, he modified it, and he is now in Julia and Python. And somebody else also did it in Java. So you can have any flavor of language. Pretty soon you'll have something in another language.
Yeah, that's excellent. and throughout the years, you developed several enhancements. Can you comment on some of them?
Yes. Okay. So over the time, we realized that there are some components in the structure that were important. Okay. So the evolutionary engine is important, but we can incorporate some know-how and make it better, okay? So the first thing that we start doing was a local search, okay? So the basic idea is that you take the chromosome from the genetic, you construct a solution, and then you improve it, okay? And that improvement, the local search, helps a lot, okay? So combining the local search is very easy. It's in the decoder, so you can do it, initially without any local search. If it works well, then you don't have to. Then if you can, then you add, and that's all. Another thing that we did after that is that now that you are using local search, you are getting to a different solution that is the one that is generated directly from the chromosome. So maybe we could create a chromosome that generates that solution directly. Okay, so we start using correction of the updating, okay, the chromosome. So I start with a chromosome, I get a solution, I improve it, and then I create a chromosome that gives me directly. And that helps in terms of quality, because when you cross over, you are crossing now the good solution already, and also speeds up. You get to the
it converges faster.
Faster, yeah. So there are two things that improve, the convergence and quality. And then in some other problems, we realize it is important to define a good fitness. Okay, so there are many problems in combinatorials where different solutions give you the same fitness. Okay? Let me give you for example, the job shop problem. Okay, so if you use the make span, there are many solutions that may give you the same make span. Okay?
Ties. You changed in between, but the final make span remains the same.
And then we say, okay, so how can I differentiate? Are all these solutions as good? Well, in terms of make span, they are as good. However, the idea is which one it's easier to improve. Okay, so that should be reflected in the fitness. So if I have two solutions, I should make the one that is easier to improve, the one that is going to be crossed over and reproduced more. So for example, for the job shop, let's suppose you have a make span of 10. If you look at all the machines, and let's suppose that you look at another one that is 9, another one that is 8, another one that is 10, 10, 10, 10. Okay. So all the machines that are 10, if you have many machines with 10, it's probably going to be more difficult than if you only have one machine with 10 and all the others are smaller.
Yeah, it makes sense.
Okay, so we modified the fitness. So the fitness now it's 10 plus a fraction that tells you whether the other values are far away from 10 or close. Okay, so if they are really far away, then you're going to have 10 something.
Yeah.
If they are very close, then you are going to get very close to 11.
So you're making use of additional information of the solution to try to guide a search. And
so now two solutions that were equal with the make span are different.
Yeah.
And that is also something that is very important in scheduling and in other things. We also use that in the maximizing the open stack problem, okay, which is also one of the and I think almost everywhere we can use that. For example, for the container loading, so you can measure the percentage, but sometimes you have the same percentage of the container filled, but one of them has a large empty space that is not being used, and the other one has many small empty spaces. So the one that has a large space, it's going to be easy to improve. Because if you have very small spaces,
you have room to improve.
So that one we also modified it. Okay, so we've been using that idea several times, and other than this, we
but that's already quite a lot of enhancements.
So we sometimes combine some of those things together. All of three, or some of them sometimes we cannot. For example, once you have applied a local search, we cannot come up with a chromosome that gives you that solution directly, because there is not a unique way of translating the chromosomes.
I see what you mean.
Yeah, so in that case, but it was the combination of those three or four things. It was, and then we applied to several programs. Okay.
Yeah, as we can see in your list of publications,
Oh,
there are many of them. Yeah. Um, in 2015, you visited Mauricio Rezende at Amazon. Um, and then later on, you spent a sabbatical period there and you ended up joining Amazon. And tell me why you decided to leave academia and how was the process to join Amazon?
okay. So I was working on, in Portugal, I got a grant. Okay, and the grant, they allow you to invite some person from another country, that is also a researcher. So Mauricio was working with me in those Portuguese grants and projects, and we've been working since I think 2005, 2006, while he was at AT&T, and we kept working. And then one of those grants that was working until 2016, one of those last meetings for the project, Mauricio was already at Amazon. Okay, so instead of going to AT&T, I came to Amazon, and I really enjoyed the environment. Okay, the problems that they were working, and the company was growing, so it was really applying, what to solve problems. So I really enjoyed the environment. So since I had the sabbatical coming in the next year, so I said, okay, let's try and see if I can come here for a sabbatical. So we tried, an application. I came for an application in January of or February of 2016.
Mm-hmm.
Everything went fine. But then, Amazon has a process of evaluating where they need to have what they call a bar raiser. A bar raiser is somebody that is trying to label the quality of everybody that is being hired, okay, or going to work. So for some reason, they did not include that type of person, okay?
Mm-hmm.
That is trained just to do that, it follows some rules. So I had to repeat the process again in July of that year. So we repeated that with all the, this time the bar raiser was there,
Uh-huh.
and I was accepted. But then, the person was in charge of the process left to another company. Okay, so I was again, forgotten.
Yeah. Limbo.
And then around the October, November, we started the process, which requires that you get a visa to stay in Amazon. And finally, I started. My sabbatical was already 3 months because we start in September. So
Mm-hmm.
September, October, no, maybe 4 months. So I arrived on the 6th of January of 2017.
Okay.
I stayed that year. I enjoyed it a lot. So I asked the university in Portugal for an extension
Mm-hmm.
without pay,
Mm-hmm.
and then I started working as a regular person in Amazon
Mm-hmm.
until today. Okay,
Mm-hmm.
so I enjoyed it a lot.
Mm-hmm.
For
Right.
OR people, this is the best you can find. Okay, because it has all sorts of problems, logistics, inventory, even for pricing, forecasting. It's really amazing, the problems that you have, and given the volume and the values, Amazon, anything that you can save, it's very good.
Yeah, yeah.
You feel really that you are having some impact
Yeah,
in
on that note, uh, can you briefly summarize what you do at Amazon, your work, and the projects you took part?
Okay. So Amazon has three main areas. Okay. It has what they call first mile, middle mile, and last mile. Okay. And maybe I should have started with the type of facilities that we have. We have what we call fulfillment centers.
Mm-hmm.
That's where you store the products, okay, that come from the suppliers. Then we have to ship the product from those fulfillment to where the customer wants them. So first they go through sometimes a sort center. The sort center divides the thing into several locations, and they end up in what we call delivery stations. Okay, so we have these three facilities, and the movement of the products from the suppliers to the FC, it's called first mile. The internal movements between a fulfillment center, sort center, and delivery station, it's called middle mile. And then the part that delivers from the delivery station to the customer, it's called last mile. Okay, so I worked in the middle mile to start with. Okay, and the first work that I did was routing, planning how we should address the routing. Also related with that, I worked on a problem which is repositioning the trailers. So when you move some product, the trailer is full, but then you have to bring back the empty trailer.
Right.
Okay? And bringing back the empty trailer is not adding value.
Yeah,
okay?
that
So
trip.
Okay, so we had to optimize that so that we could save money. Okay, and then also related with that, Amazon has aeroplanes. Okay, so we need to also do plenty of the aeroplanes. But one of the things that we need to do is that we have to make sure the aeroplanes are available. And to have the aeroplanes available, we need to have the aircraft engines available. So I also worked on the planning of the maintenance of the engines. Okay, when they should be removed, when they should be repaired, if we have enough engines to replace in the aeroplane, shall we buy them? Shall we lease them? When should we replace them? And finally, I moved to the last mile. Okay, so last mile, it's very close to the customer. And in this particular area where I'm working, Amazon is a kind of Uber like workers that supply products for us. They are individuals that Amazon tells them, would you like to work for us every day or several days a week? So people who have a car, they just put some packages in the trunk and they deliver them. We call that Amazon Flex because it's flexible. And we need to plan that. So planning, that means how many drivers I need, shall they work a lot of time or not so much, when they have to start. And also we have to make the route. So we have many routes, and there is a lot of uncertainty in these kind of things because sometimes if it rains, people don't like to work. Then we have price. Sometimes the price goes up, sometimes the price goes down. So you have to make decisions whether they are short term or they are a little longer. Because if you can decide the longer term, usually you get better prices. So that is the kind of problems that I work.
And regarding methodologies, are you allowed to comment on what you guys do?
Well, I can tell you some of the tools. Some of them are mass programming. Sometimes with uncertainty we use stochastic programming by using several scenarios. Sometimes we use simulation. I cannot go into the details,
Yeah, of
but
course.
The tools are, and then the scale. One thing that we have to be aware at Amazon is that we need to solve very large problems very fast. Okay, so sometimes you have an approach that works very well if the problem is smaller, but if it's too large, then it doesn't work. Okay. And we need to have sometimes, so we have to sacrifice quality, the optimal. We don't have to, we know we are not getting the optimal, but we are getting a solution very fast, and we need to revise it. So yeah, sometimes it's not just quality of the solution, it's the combination of all those things. but it's really enthusiastic, and it's very exciting.
Yeah,
Work.
there are many applications, especially in logistics, as you mentioned, and certainly there might be many opportunities to put OR in practice, and to get optimized solutions that will be
Yeah.
result in a lot of profit for Amazon.
Yeah, I think almost everywhere you have the opportunity of using OR. Okay. Well, I never worked in in the department that we call AWS, which is Amazon Web Services,
Mhm.
where you have the possibility of buying a virtual computer. Okay.
Oh,
So over there, you also have the problems, what computers I should buy, how to allocate, because these are virtual computers. So I can give you now that computer for 2 hours and then use it for another person for. So we have to constantly be, allocating those things. So that also has. But there is also machine learning, a lot of machine learning, especially in forecasting,
hmm,
because there are many parameters going into there. And I don't know if you know, but Amazon makes a speaker it's called Alexa.
yeah, very famous.
Yeah, so this kind of speaker uses a lot of machine learning to understand what you say. And so I think Amazon became also a company that is expert in machine learning. Okay, they even have an internal university called the Machine Learning University.
Yeah, they're really taking it
So,
seriously. Yeah.
yeah, so they have opportunities, and most projects are secret. So there are many things going on.
Yeah, let's see what happens in the next few years regarding the
I think
advances.
one of the things that many people know is that we are working with drones,
Uh-huh.
and so soon we will probably start delivering things with drones. And there are some ones that go in the payment. They go and they deliver.
Uh-huh.
So that becomes more reliable, because these kind of machines, they work whether it's cold or not cold. They don't feel tired. Driving trucks is also one of the things that it's publicly known, that like Tesla has those cars that drive self-driving.
Mm-hmm.
So self-driving trucks is also something that it's important for delivery.
Mm-hmm.
But it's really amazing.
Yeah, one can tell that Amazon is putting a lot of effort in analytics, OR, machine learning, and it's certainly, I would not say dominating the field, but it's a company that it's certainly attracting a lot of attention and many employees as a result. Right?
Yeah. Yes. So when I started, I think there were around 350,000, and now I think it's around 1 million.
Yeah.
So
Wow.
it
But
really went up.
yeah. But José Fernando, tell me, any plans of retirement?
Well, I'm now 62, so I'll have some plans, soon. I don't know when, but in Portugal, you can get retired around 66.8 months. Okay. So, yeah, sometime between now and 67, I'll probably do that.
Mhm.
Yeah. But right now, I am.
But then
I'm still.
you'll return to Portugal, to Porto, and be there.
Yes. So yeah. If I do retire, I'll go back to Porto.
Hmm.
Okay. And um, I don't know. I may also consider going back to Portugal and work in Amazon there, in
Hmm.
Amazon Europe or something.
Uh,
But right now, I have nothing really well defined.
yeah. Well, José Fernando, it was great to have you here. I had a lot of fun talking to you. Uh, so I hope you had a nice time too.
Well, it was my pleasure, and I thank you very much for the invitation. I think you did a great job just preparing all that. Yeah, it was an amazing work. Thank you very much. It was my pleasure.
Thank you so much. Muito obrigado, José Fernando.
Muito
I
obrigado
can't
também.
wait to visit you in Porto when you were there. And of course, you're
Yeah.
most welcome to visit us here in João Pessoa, here in Brazil. Okay?
Yes, I'll probably do that as soon as I can,
Yeah. So,
with a lot of pleasure.
yeah. So take care, all the best, and see you soon. Tchau.
Thank you.
Até
Ciao.
logo. Bye.
Até logo.